420 minutes to run this algorithm.
Mm. Are you trying to share your screen?
Um, I no, I have sent. Yeah, I sent the picture
Oh,
into
I'm so
Discord.
sorry. Okay, I got it. Okay. Um, next step. Oh, you tried it. Okay, I see that. Okay.
You guys can share your screen now.
下下。
What?
Share screen.
I think you two discuss your file. Maybe you can share yours.
Okay. Share my screen.
Oh, you did the grid search. Yeah, I don't know why I didn't do that with mine.
Okay. Never mind. Okay, that's just getting. We have got the result. That's fine. Okay.
Yeah, okay.
Maybe my computer. Maybe because of my computer. I think.
Yeah, maybe, or I didn't do the grid search. That's probably why yours took a while.
Took a while.
Because you tested like different variations of parameters. Like you tried every variation
Yeah.
from
Yes. Yes. I think.
right. Yeah, I see that. Yeah. That's probably why it took so long. I just
I mean the depth is too deep, and the split is too how to say separately. Is
mm,
to yeah.
yeah, okay. That's probably why. Okay.
Okay.
I guess I
Okay,
just
that's
tried
fine.
different techniques for mine.
Yeah. So where's yours? The
Uh
parameters. You can share your screen. You can share your
yeah, I
screen.
will. I didn't really do a lot of variations. Whatever. Share screen. Okay, so I loaded it in, separated the class from the other features. I did different splits that ended up being 0.3 for the test size ended up being the best.
Oh, maybe I can try 0.3.
Yeah, you can try 0.2 and 0.3. Those are the other two common ones. I noticed that you did 0.4. Yeah, it's fine. Anyway, yeah, this is the only other thing that I set. I only set
Entropy.
the,
Okay.
that did a little bit better than the other one, weirdly enough.
Oh, I use entropy and the Gini too. I use two. Maybe, yeah. Okay.
And so obviously probably got similar confusion matrix. So here are the results. The false positive rate really low, less than 1%. False negative rate super high, 42%. And then the accuracy really high, probably because of this up here.
Oh.
And then, sorry, and then the F1 score super low.
F1.
So I was describing based on our success criteria, accuracy still at least 80%, false positive rate still at most or still below 5%. It's important to note that while the false positive rate is 0.9%, the false negative rate is 42. So I tried undersampling, which the majority class is reduced to equal the minority class. So right now, I combined the test and training data set into one. So that's why there's over 1 million in class 0 and then about 20,000 in class 1. So I tried undersampling the 1 million to meet the 20,000. That's what this cell does. And so then I did the same. I changed the test size to 0.2. I don't know why I ended up doing better at 0.2 than 0.3. But I did the same parameters. And so it ended up looking like this, which ends up looking, the true positives and the true negatives are a lot higher than last time. So the false positive rate increased.
Yeah, increase more.
Yeah, but I thought it was worth it because the false negative rate decreased from 42% to about 15%. And then the accuracy got to about 84%. And then the F1 score also 84%. Like, yeah, the accuracy decreased, but the F1 score increased. So I feel like for our success, it kind of matches a little bit better. I don't know. We can argue about whether it's not better or if it's worse.
Okay. So how about the Hessians? So what was your accuracy?
My part is together with Xiaxia's part. You can share that.
Oh yeah. We do the XGBoost and LightGBM.
Alisa also have some.
Sorry, yeah, I did the cross validation just to average it out, and the standard deviation is really low when I tried 5 different folds. And so this is basically the average results that I got. Anyway, okay, now I'm done.
Okay.
Okay. Check. Me and Heshun do the LightGBM and XGBoost, and of course we do the train and validation split, and I remember we split as 7 to 3. I remember. Let me check percentage. Okay, no worries. I'll find that later. And then we do the XGBoost. And we got 14 minutes, and the accuracy score is 98.62, and the confusion matrix is like this. And this is to plot of the evaluation of XGBoost and the error evaluation of XGBoost. And the blue thing that is covered under the right is the correct answers of the test of the validation data set, and the right is our prediction. And the yellow and the gray part is the correct data set values, and it's ours minus correct data value set. So if it gathered at the 0 line, that would be nice. And the next is LightGBM, and the accuracy is 98.76, and this is the confusion matrix. And I think LightGBM is better than XGBoost because we have I think we have less it's NP, yeah, FP, and it has higher FP and also has less accuracy score. That's all we do. Do you guys have any question about that?
No.
No.
Okay.
So Kunlun's.
Hello.
Mm-hmm.
I changed my model to Cat Boost and use the same data as He Xuan and Yi. Cat Boost splitted the data to 5 parts, and I think the accuracy of my model is 96%. The best one is 96%. This is the result.
So the most accuracy is light GBM so far.
A little bit lower than
That should be a
a little bit lower than the accuracy is a little bit more than the previous 2 models.
So we're gonna choose just one for deploy, or one, or so how many we need to deploy from the requirement of our assignment.
I think we have to do some comparison work and get the final just one model to deploy.
The last one should be only one because the professor side deploy the most suitable model. Yes.
How about Supriya? I think Supriya is in the Zoom meeting. Supriya, do you do any model? Do you want to show your screen?
Yeah, I'm actually working on it. The SVM
we can hear you.
It's actually, the SVM is taking some time and I'm still trying to adapt with the assignment. So I'm almost done with it.
Okay, so mean you didn't do your model so far, right?
Yeah, not yet.
Okay. Now we have 5 models. So maybe next we'll discuss about the comparison work. Do you think we can compare with AUC to rank? Do you guys have any other ideas?
Yeah, I think 5 models it's enough right now, and we can just finish the 6, 7, the bullet points of the assignment, 6, 7, 8, and then choose the best one, the most suitable one to deploy.
If we're going to compare, should we use just the first model that I did, which was without balancing, since all the data for all the models that we're comparing is the same?
Oh, you mean we do the same procedure with you, and so we can have the same data set, so we can compare with the different basement, with the same base. Do you mean that?
Yeah, not saying that you have to do the same thing that I did, but I'm saying maybe just if we're going to compare, just compare your models with the first model that I have, which was keeping it unbalanced.
I think I understand. You mean we unbalance our data set and maybe do the same percentage to split. Do you mean that?
Yeah, I mean, you guys didn't balance the data at all, right? You guys just kept what we did from the previous assignment.
Yeah.
Okay, yeah, then yes, then I just compare your guys' model with the model that I did, or the first one that I did before I balanced it.
Oh, I think I know what you mean.
Yeah.
Okay.
Because even though I like the results of what I did the second time, I don't. It probably the comparisons won't be completely. I don't know. It won't be total. I don't know if they'll be accurate, but.
No worries. We can use your first
Like-
one and Supriya, please say.
For comparing, like you're just seeing the accuracy of the algorithms, right? Like the runtime and the accuracy which you got when you run your algorithms. Is that what you're going to compare? Is there any different criteria for that?
Did you ask for comparing runtimes?
Yeah, like how are you going to do this? Like the comparison, like based on the runtime or based on the accuracy, or how is it going to?
Yeah, we can have 2 or 3 parameters to compare, like AUC, accuracy score, runtime. I can run all the models in my computer so we can get the same hardware specifics.
Okay.
Cool. So, Xia, you'd like to do the comparison part, right?
Yeah.
Yeah, as a conclusion, okay. So I'll take the point 8 to see the business issue, if there is any.
Okay. So
Yeah.
we just determine we compare with AUC, accuracy score, and runtime, right? Do you guys have any advice to compare?
Right now, I think that's what we can take, right?
Does the ROC wait? Wasn't there another way to do it?
Should we
Didn't the professor use?
Yeah, should we check the professor's lecture? And I think he talked about something.
Yeah, it was in lecture A7.
Yeah, let me see as well. We have a confusion matrix, right? For each.
Yeah. I think so.
Yeah. And
the confusion matrix is only just maybe for the classes, or can you do it for all the parameters?
Sorry, Supriya, could you please pardon?
For the confusion matrix, according to the professor's lecture, it says it's only like he performed it only for most of the classes in the data set, right? He just chose one class, and he did the false positive and the false negatives for that.
maybe I'm misunderstanding, but we only have the output is there's only two classes, so that the confusion matrix is only going to be a 2 by 2.
Oh,
Is that what you meant? I guess I don't understand.
Yeah, right. According like in the lecture slide for the confusion matrix, the professor took only one class and he just chose did for one class. So are we going to do the same thing, or are we following some other method for this?
sorry, I don't.
Oh, I see. In the lecture, the professor assigned model summary of testing methods holdout K4 cross validation. Leave one out, cross validation, like many kinds of validation. Model selection using statistical test of significance. Yes. And t-test, like, and also ROC curve and AUC. So AUC is area under the ROC curve. We can pick one of them, or what? Almost these things in A7, the last few pages.
Hoshiro, do you mind sharing this
Okay.
to yeah?
Can you see that?
Yeah.
Hmm. I didn't quite follow this part on class.
Me too.
The first part, confusion matrix, and then bias, variance, and product. Cross validation. But I think this means one for train and the other for test.
I think just Allison used the cross validation method.
Yeah. And satisfied. When you are looking for relatively low bias and variance in the computations needed. Here summary for testing. This thing. Selection is statistical test of significance. We generated two models and perform. How can we determine which is the best? So we do the t-test. And the last one is ROC curve and AUC. I think you did this, right? Before?
Oh yeah, I think everyone has done the AUC. I think it's easy to do that in the model. I'm not so I don't so understand about the t-test.
Should we use this, right?
I'm not sure. Is that what that thing? I don't know.
Alison, what do you think? You prefer we search and try to do the t-test, or we can just use ROC curve and AUC?
Right, because that the ROC and AUC, that's used to determine which model is better, yeah?
Yeah.
Yeah,
Okay, let's just use ROC and AUC maybe.
yeah,
Okay.
I don't want to do the t-test.
Me too.
I see. Okay, so let's do this. I think we can handle it.
Okay. And I can also do the runtime. So okay.
Okay. And when we get the decision, we can use the most suitable model to deploy the whole project.
And the
And-
deployment is easy. I think
Yeah.
we just deploy it. Do you guys think we should unify our percentage of the split? Because
yeah.
I use 20% for my validation, and I can change that. Alison, you use 30%, right?
I used 30 for one of them and then 20 for the other.
30. What is 30 for one another?
When I kept it unbalanced, it was 30%, and when I balanced it, I changed it to 20.
Oh, I see. So and we wanna we're going to use your first one. So
Yeah,
yours
yeah,
is 30%.
yeah, 30. And then House was, I think, 40. I think
Yeah, his is 40. So let's change to 30.
Yeah. Okay.
Okay.
夏夏 then you tell Hao this decision.
Okay.
Okay. And then I think we should make do you want to make the PowerPoint slides this time? Because we don't have we have to. I'm sorry. I see the deliverables. We have to. Okay, I'll make a share file later, and then we can paste each of the important parts of the model. Yeah. And then you may have to take more time to work on this.
Okay, no worries.
In advance.
Okay.
Okay.
Wait, why do we have to have a PowerPoint? We're not presenting on Monday.
Yes, but it's easier for us the next week because we can just paste it to the final presentation slides. Yeah.
I guess.
And I think we can have a meeting after the next week, next Monday. Then we decide each of us what to do.
Okay.
For the final. Yeah. And this time we can just focus on the models. I think that would be good.
So what are the let's see, the deliverables that includes the ROC or AUC curve for this assignment?
You mean assignment 6? A size you see the interprets the models according to domain knowledge, success criteria, and desired test design, and rank the models and access the models according to the evaluation criteria such as performance, efficiency, and everything else. And then it's we see the business objectives and to deploy the most suitable model. So I think this is a process to choose the best one. We have to rank and compare. So
right. I mean, so it's not really we're not really deploying the most suitable model. We're just like choosing it because I guess we're deploying all of them. We're running all of them.
Yeah, it says deploy the most suitable. So I think we just need to deploy the one of the models. What do you think? is the most suitable model, I think it would be 1 or 2. It doesn't matter.
I guess I'm confused by the word deploy. I mean,
I think that's we have to work on the test data sets. Is that correct? Because when we design the models, we use train, and then here we do the test.
Okay. Did I guess I forgot. Did anyone get a R F1 score of like 80%?
No,
No.
I don't get it. I don't do the F1 score. Maybe I can try that.
Yeah, because I remember him saying that we use the F1 score, not accuracy, when our data set is unbalanced.
Yes.
Okay, I'll do the F1 score.
I'll calculate the F1 score in my model.
Okay. Cool.
Yeah, that's why I included the F1 score in mine, because I remember him saying that.
Yeah, okay.
I guess I'm not sure how we're gonna. I'm not sure how
So
we're
maybe
gonna
I
choose one.
can compare F1 score and UC and runtime.
And accuracy.
Yeah, and accuracy.
We can compare and we can say but since we are unbalanced data sets, this is just for reference, and we prefer to see the results of the F1 like that.
Maybe I can just do the table and we can discuss who would present that, who would introduce that.
Yeah, that would be very fast because we have only 20 minutes for all of the project from the beginning to the end. So for the models, we can talk more than other parts because this is the only part we didn't present to the professor. Yeah, but it would be really fast, I think.
Yeah, sure.
Yeah. Okay. Okay, so it's almost done, I think.
Okay.
Xia, don't forget to tell Hao Ge the two
I'm
parts.
here.
Oh yes.
Listen.
One is percentage and the other one is F1 score.
Yeah.
Yes, I've done the F1 score. You can see my results. Yeah.
Okay. Hozor, will you create the file in Google Drive to?
Yeah, sure. I'm doing
okay.
that. Okay.
Okay. Thank you.
Oh, yeah, okay, yeah, I see the F1 scoring separated it by class. How?
Yeah.
Okay. So I wonder if like the F1 score is like the average between those two F1 score.
Let me see. I'm running my algorithm again, so I can't stop it.
And I guess so, because see.
Let's see. F1 score the negative and positive.
What's negative and positive?
Yeah. Don't just ignore the bottom part and just see the first two line the first two line.
Yeah.
Yes. So, okay. So we were done?
Yeah.
Yeah, I think so.
Okay. Okay. And so when is the next meeting?
Can we make it maybe next Tuesday? Because we have 1 week to finish the final report and presentation.
So what's the deadline for this assignment?
The
Monday.
next this one's assignment 6 is next Monday.
No, it's
And
this
the
Monday, isn't it? It's this
next
Monday.
next Monday, the upcoming Monday.
Upcoming Monday. So
yeah.
in 4 days.
Yes, and then the next week is the presentation for the final, and we have to rearrange the report and do the final presentation slides.
Okay. Okay. So the final just a PowerPoint. So we need to submit another PowerPoint for the final.
Yes, another, and also the report.
Also the report. So this is another deadline. So,
Yes.
okay.
So, I guess, should we meet Monday to make sure we finish the the presentation slides for this one?
Yeah, yeah. The last day is Monday.
So I guess that's what we do before the due date, I guess, is to fill out the PowerPoint.
Yeah.
Okay. And then are we all doing the AUC or some of us doing it?
Xia, what do you think? Do you need each of us to do it, or yeah, I think we each of us should do the
Yeah, it's better.
F1. Yeah,
Yeah,
and then
it's
send
better
it
everyone
to
do that.
Xia. Yeah.
Just feel free to push it in the GitHub if you finish that.
Oh, I see. So we're just doing the AUC for our model, and then we compare each of the AUCs to like the 5 or 6 that we have.
Yeah. And also the F1 score and accuracy score.
Right. Okay. And so How does it need to do it? Because I think he has his AUC already, yeah?
Now I can try. I can change my parameters to try it again.
Yeah, I'm gonna do something similar to what you did, so I can test a whole bunch of
Yeah, I just get
parameters.
rid of the Gini index. I just use the entropy to try it again. And depth, we can set it. I can set it less. Okay, I'll try it. I'll try it.
Try what?
I'll try to run it again. Run my algorithm again.
Oh, why do you need to? I'm confused.
Sorry?
Because it looks like on your code you tested a whole bunch of parameters in once. That's what the grid search CV does.
CV. CV does.
Yeah, doesn't your code?
Yeah. What is your question? I see.
Oh, I was just saying I'll probably follow your code a little bit because since your code tries a whole bunch of different parameters, like I'm looking at the param grid, and so the grid search CV, it goes through each combination of your parameters and tests the best one, I think.
The param. Could you have can I have your screenshot of your parameters? This is for your parameters? No, this is Xiaxia's. Listen, okay. So what's your parameters for your algorithm? Can I see it?
Well, I didn't really test a whole bunch. I mean, I didn't test a whole bunch. I just changed a couple manually. I get
Oh.
stuck to the criterion of entropy.
Yeah.
But I think if I have the time, I might do something similar to what you did
Okay.
and create like a parameter grid, and then use the grid search CV to find the best set of parameters
Mm-hmm.
and get the AUC. Yeah, I might do something similar. I don't know if my computer's faster than yours. I don't know, but
Okay. Okay. Oh, that's fine. Okay.
yeah,
Thank
if
you.
it does, if it runs for however long yours ran, maybe I won't.
No. Okay. 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 Thank you. And okay. So we are done, and let's keep doing. Okay.
Yeah, I think
Yeah.
so.
Bye bye.
Okay, see you guys.
Bye.
Bye bye. Bye bye.
Bye.
Bye, guys.
Great.